is the DeFi Decoded podcast by 9 Point Partners. The ideas and opinions expressed in this podcast should not be taken as investment advice. Always consult with your financial advisor before investing.
Hello and welcome back to DeFi Decoded. I am Alex Tapscott here with Andrew Young. This was a big week for Ethereum. The long-awaited Dencun upgrade occurred, and in typical fashion, without any hiccups and not all that much fanfare. And I think in a way it's almost like those Starship launches. Once they become routine, that's when you know that they're successful. And I'm feeling the same way about Ethereum. The network upgrades seem to be happening kind of like clockwork. Even still behind the scenes, it's anything but. Maybe it's not a rocket launch, but there's certainly a lot of different moving parts that go in to making these things a success. And we've got the perfect person on the show today to kind of talk about that, not only about Dencun, but what's next for Ethereum and really the blockchain space as a whole. And that's Tim Beiko. Tim, welcome back to the show. We had you here the last time. I think it was either just before, or I think maybe just after the merge, which was the biggest sort of event for Ethereum in its history, I think, other than perhaps the launch, obviously. But this is obviously an important one too. So why don't you tell us, just put it into layman's terms, because I think a lot of people have heard this thing, but they don't, unless they're deep in it, they don't totally understand all the implications of this network upgrade, what it means for Ethereum, what it means for applications being built on top, what it means for users, what it means for enterprises who are considering building on Ethereum. Like, there's so many different stakeholders now that are impacted by changes to the network. So we need someone to help demystify that. So no pressure.
Yeah.
Please go ahead.
Yeah, of course. Thanks for having me back on. It has been a while. So as you said, the upgrade we just had was called Dencun. There was a lot of stuff in this upgrade. It was one of the biggest, actually was tied by count for the largest number of changes in a single upgrade to Ethereum since the launch. But it also had one huge change as part of that, which was what we called Proto-Denk Sharding, or EIP 4844. And that's really like the main thing that people were excited about in this upgrade. And in short, what this does is it reduces the fees that users pay when using a layer 2 scaling solution on Ethereum. We've seen the upgrade go live almost a week now. We're recording on a Tuesday, so by the time this gets out, maybe a bit more than a week. And fees have dropped by, probably 10x, if not more, across all the layer 2s on Ethereum. And this was really like the main thing we wanted to bring in this upgrade. We can go into the technicals of like how that actually all works. But as a user, or as like a sort of someone interested in Ethereum, this is probably the number one thing to understand is it's helped scale Ethereum layer 2 adoption, and it's helped scale Ethereum layer 2 adoption, and that's resulted in lower fees for users.
So to quantify that, like, someone's paying a fee of how much on a layer 2 to do a transaction versus before the upgrade?
So it depends on the layer 2 and the type of transactions, but I mean, I've had transactions that would have cost a couple dollars before. So, say swapping tokens on something like an optimistic rollup, like Arbitrum or Optimism. And for a while this week, those were like 1 cent, right? On Base, which is Coinbase's Optimism deployment, the fees were like less than 1 cent, and the wallets did not anticipate sub-cent fees, so the wallet would like show zero, even though there was some sort of fractional cent.
Oh, that's
fee.
amazing.
So it obviously it's always a function of supply and demand. If a bunch of people show up next week and use the L2s, the fees will go up. But just as like a difference between like right before and right after the upgrade, it was something between 10 and 100x difference depending on the use cases. If you look at charts of the price, you sort of see basically a steep step function fall to effectively zero relative to where things were.
Yeah, it's pretty huge. It really makes a lot of use cases sort of economically viable once again on these layer 2s, which is great to see. Also, kind of comes right in time, right when Solana has really sort of taken over a lot of mind share on just in terms of like where crypto Twitter attention is nowadays, especially with retail starting to come back in. So I guess one sort of sort of criticism or counterpoint is, won't this this is obviously a huge upgrade, but won't it effectively create like induced demand? So like create a ton of new demand for block space on these Ethereum L2s, and then eventually the fees will come back up. Not really saying I sort of subscribe to this opinion, but I guess how sustainable do you think sort of these lower transaction fees are going to be in a like crypto bull market, I guess?
It's super hard to predict this. I mean, fees are a question of supply and demand. Like we have limited block space, people bid for it. And if there's more supply that comes in, the price will go down at a specific amount of demand and then vice versa. So I don't think you can really make any predictions. Like, if more people come, then yeah, obviously the fees go up, but then you're serving more people at that same fee level, right? So instead of having, X amount of users paying $1 per transaction, then you have, 100X or something like that. And I don't think there's much you can do to plan beyond that, right? Like if you're working on the protocol, your only lever is like, can you increase supply in a way that maintains, the security properties of the network? And that's sort of the lever we have. The other lever is like demand, and it's like, can we get less people to use Ethereum? That's probably not like something we can even control. So yeah, the way I think about it is just, can we like change the supply side of the equation, do it in a way that is still obviously secure and give users like high assurances that the chain they're using is stable. And beyond that, if people show up to take advantage of those fees, there's no, it's a permissionless ecosystem. Like people are free to come and use the chain for whatever they want.
Yeah, I'm not sure I totally understand that argument, because it's like, if you had a 2-lane road and then you added a bunch more lanes and more cars could go on it, therefore more people could get to and fro. It's like worrying about traffic down the road on a hypothetical highway where you've added all these cars or something, right? Or like, it's like, that's a good problem to have, I guess, that the network's grown and so more people want to use it and it's more useful. I don't know. Are people in the Solana world making that argument, Andrew?
Yeah. It's just kind of, well, I guess the sort of the reason, what flows from that argument is, I guess, the idea that, we, up until this upgrade, we've been adding more sort of scalability to the Ethereum ecosystem horizontally by just adding tons and tons of L2s. Like I think we're now up to maybe 20 or so L2s last I checked. Actually, maybe even more. And the cost of launching a new L2 has just gone down dramatically now as well, with like OP stack, all those things. So I guess one of the sort of again, I'm parroting the Solana FUD, not that I agree with it, is that it, in some ways it's obviously really good, but it also kind of like negates the need maybe to have so many different L2s. I'm curious what you think on that.
Yeah, I don't think I agree. So I think you can think of many different L2s as just effectively it's like different state space, right? Like when you deploy a contract on Ethereum or on a layer 2, it has a specific address on a specific chain, and by default, it's composable with everything on that chain. So, if you're using Ethereum L1, you have all the Uniswap pools from Ethereum L1, you have the ENS registry from Ethereum L1, all that stuff gets to like interact together for free. And this is the same thing you get on like an L2, right? If you're on like the main Arbitrum chain or the main Optimism chain, you get like a specific state space where there are, DeFi pools, there's NFTs, there's whatever you have there. And then when you deploy a new L2, the trade-off you're making is that you agree to not have like direct access to those existing state spaces, sort of need to redeploy everything from scratch at the benefit of not having contention for that existing state. So if I'm using, say, Ethereum Layer 1, Uniswap is one of the biggest gas users on Ethereum Layer 1. Every time you're making a transaction, your transaction is effectively competing with somebody who wants to use Uniswap for whatever reason. And so if you have a set of use cases where those use cases are very independent of that, then deploying a specific L2 could make sense, because you're saying, we're going to have like a priority lane on our highway, which is just, separate from everything else. You sort of have to bridge into it, but then while you're on it, you don't have all these other cars from these other lanes kind of coming in your way. And And this is kind of the, the trade-off of like, should you have a new L2 or deploy on an existing one, is like, how much do you value being interconnected with everybody versus having your own like less contentious state. But then with something like Forward 4.4, what we're doing is we're lowering the cost for all of those L2s. So the main component of a transaction fee on a layer 2 is that these layer 2s have to post that transaction back to Ethereum layer 1, so that if there's ever contention about whether a transaction was valid on a layer 2, you can always look to layer 1 and dispute that. When people talk about fraud proofs, this is basically how the mechanism works. It's, you have a layer 2 posting data on layer 1. When you withdraw from a layer 2, there's a delay. And the delay is there so that people can look at the data on layer 1, make sure that that data was correct, that there was nothing weird going on there. And then if no one sort of disputes your withdrawal, you're free to go. And this is why L2s are sort of secure in a way, because you know that you can always go back to layer 1 and kind of adjudicate a potential invalid transaction. What we're doing with this upgrade is that prior to it, the data that was posted to layer 1 had to stay there forever. So L2s would have to pay a lot of money for that because they're paying for like infinite duration storage. And L2s, though, they only need that data to have been there for a couple weeks at most, because on, say, something like Arbitrum or Optimism, when you make a withdrawal, after 7 days, your withdrawal is free to go. So there's nothing anyone can do at this point to like, contest the transaction that you made. The security assumption is that if something was wrong with that transaction, within the 7-day window, somebody would have brought it up, paused the whole thing, and adjudicated it. So with this upgrade, what we effectively introduced was temporary storage on Ethereum, where we have this other data storage system that gets deleted every 18 days or so. And this is really valuable for L2s because it allows them to post all their data there, have the data live long enough that anyone wanting to dispute this transaction has, sufficient time to do so with a very large buffer on both sides. But then because the data gets pruned every 18 days, it's cheaper to post that data to Ethereum than paying for infinite duration storage. And this is where the cost savings come from. So we can still have tons of layer 2s. We're not like bottlenecked on that. But the thing we've introduced is a way for layer 2s to post data to Ethereum that's only made available for a few weeks. And then even once that period is done, though, you can always verify data that you've gotten from somewhere else against the Ethereum chain. So the Ethereum chain is telling you for 18 days, you can download everything from here. After that 18 days, if you bring some random piece of data and you want to check, hey, was this actually part or like committed by some layer 2, then you can verify a cryptographic proof on Ethereum layer 1 and get a result of that. But for 3 weeks, basically, you have everything available on L1. And again, the L2 kind of dispute window is 7 days. So this gives us a significant buffer on both sides of that.
So maybe I'm not technical enough, just so I understand. Like, does the data that is in that transaction, is it searchable later on anywhere else? Like, what if the transaction is involved in a crime or a civil dispute, and you need to find evidence of it for like a court case or something.
So you can't rely on the Ethereum peer-to-peer network to get that. So
Okay.
You can get it from anywhere else. If Etherscan has a copy, or if some other place archives a copy, and obviously you can run a copy yourself. If you run an Ethereum node, you can keep it.
Yeah.
But then say that like you show up today and you want data from like we call those blobs, that temporary data. If you want data from a blob 6 months ago, you're not going to be able to connect to the Ethereum peer-to-peer network and get it from there. But if you get it from another source, you'll be able to verify against the Ethereum network that this data was valid. That, if I tell you, oh, you're looking for the blob from like May 16th, 2024, I say, oh, here, here's one. You don't have to take my word for that. You can go and you can verify that.
So like, it's not like Etherscan's copy. You got to trust Etherscan. It's like you can still check Etherscan's evidence of that against the
peer-to-peer network. Yeah.
Oh,
forever.
wow.
Yeah.
I'm sure there's a way to how that works. How does that work?
So basically, So the data and the proof, they're basically cryptographic commitments to the data, and so the signatures. The signatures are stored forever. So the proof. Basically, the proof is stored forever, and then you can verify that like a specific input results in that output proof. Off chain, basically using data, using like the current state of the chain. Yeah.
That's amazing. That's so interesting. Yeah. I have more questions. Andrew, do you want to jump in?
Yeah, no, I guess looking forward, what is kind of coming next on the Ethereum scaling roadmap? What are you really excited about?
Yeah, so there's basically two tracks to the scaling roadmap for Ethereum at this point. One is what we're just talking about. How do we scale layer 2 usage? And the thing that's nice is with this upgrade, we've sort of set up all the scaffolding to scale, and we've had, like a first kind of bump up in scale, but we have a bunch of other scaling plans around this like temporary data solutions that are going to take a couple years to deploy, but L2s will not have to do anything to support that. So now they had to like move from using this permanent data storage to the temporary one. And as of this recording, I think all the major L2s have completed that. But as we keep scaling the amount of blobs and the size of blobs on Ethereum, L2s will get those savings for free. And at a very high level, the way the scaling roadmap works is before this upgrade, we only had permanent storage for everyone. Now we have permanent storage and temporary storage, which is cheaper. The next part of the scaling roadmap is what we call data sharding. And the idea there is that instead of every node on the network storing all of the data, we have nodes store a subset of the data and then query other nodes on the network randomly and ask them for proof that they have data, and effectively get a really high probabilistic guarantee that all of the data is present. So you could imagine, if there's like n amount of data pieces on the network, you don't have to query every single one to know that like they're there somewhere. You can just query a random sample and get a super high probabilistic guarantee such that the odds that like a specific piece of data was missing is something like 1 in some huge number. And this is effectively, oh sorry, please.
Oh no, yeah, please go on. I guess my thought was initially, doesn't that sort of lower the security a little bit? But I guess what you're saying is the probability is so low.
Correct. So I was going to say, yeah, we do rely on probabilistic security for pretty much everything. Cryptography effectively works the same way, right? Like when you have a public key and a private key, you're relying on the probabilities that like nobody else would be able to guess this private key, and this is a tiny probability. And we already have that throughout sort of the Ethereum stack. So this is basically the next step in scaling. So we go from like permanent data for everyone to temporary data for everyone to then temporary data for a subset of the network and like super high probabilistic guarantees that the data is available somewhere. And the idea there is that we want to scale the amount of data on the network without scaling the amount of work that a single node on the network has to do. Because the obvious path to scaling is we could just say, look, we're going to raise the data on Ethereum, by 10x, 100x, 1000x. But then what happens is you can't run a node, right? Like I couldn't run a node on my MacBook if, you need something like 100 terabytes of bandwidth per month and, dozens of terabytes of storage because you're storing all this data. So what we want is like, given a fixed amount of resources, can we increase the amount of total data throughput? And one way to do this is to reduce how long it's stored on the network, which is what we've done. And then the other way to do this is to just fragment it and distribute it and, go from having like 100% guarantee to near 100% probabilistic guarantee, and then scale the amount sort of another order of magnitude or two that way.
So,
yeah.
Sorry, yeah, no, that makes a lot of sense. I guess I was just going to interject as well. Like that would obviously, there's sort of like a big narrative going on, right? Or again, using the narratives that some people are sort of advocating for sort of raising the gas limit from 30 million to 40 or 50 million. I guess I'm curious how this sort of negates the need to do that.
Yeah, so I think everything around raising the data throughput on Ethereum effectively helps scale L2s, but doesn't do much for L1. It does in like a marginal way where like the L2 transactions that were competing for gas for that or competing somewhere else, but effectively you can consider it like a zero scale for L1. So we have this other route to scale L1, and there the bottleneck is different. The biggest bottleneck on scaling Ethereum layer 1 is what we call Ethereum state. So the state is everybody's accounts, all the smart contracts, all the data in the contracts, and all the code. So for example, I have an Ethereum account. It has an ENS. So like in the state, there's somewhere that says, my account 0x1, blah, 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 has like an ETH balance. Then there's an ENS contract in the state that has, rules about like people can buy and sell ENS names. And then it has storage, which says Tim Beiko.eth, maps to this Ethereum address that I have. And this isn't even like the history of the blockchain. It's just like a current snapshot of everybody's accounts, all the NFTs, all the tokens, all of that. And this keeps growing over time. Obviously, as there's more tokens on Ethereum, there's more applications, they create an increased state space. And this is what we're bound for to scale the gas limit is can you keep a copy of this, on a node? And right now the state is somewhere between high tens, like somewhere between like under 100 gig to like 1 to 200 gig, if I have the number correctly. Paradigm just had a great blog post on this. Maybe we can link that in the show notes, which explains like how big the state is, what it's made up of, and whatnot. But think of it as like 1 to 200 gigabytes already, which is not like an insane amount, but it's also within an order of magnitude of like what you can have on a laptop. So if we 10x, say, the block gas limit and the state went to like 2 terabytes in a year, that'd be really bad. Like, then it becomes hard to hold this whole thing. So the main scaling solution is what we call stateless clients.
Can you explain why would it be bad if it was 2 terabytes? Because that means the average person couldn't run a full node.
Yeah, exactly. So, and then if you can't run a full node, you can't verify that like when I get a transaction, like say you send me some coins, what's valuable with a full node is I can verify that your transaction followed the protocol rules, independent of anybody else, right? And obviously you do this for all the transactions on the network. You don't just pinpoint one. And this is why when people talk about like decentralization, this is like the property that's important, is that anyone can just connect to the network and verify that transactions are correct. And effectively, imagine a world where we didn't have that and only validators run nodes. Then validators can all choose to like, mint themselves a bunch of ETH, and no one's like checking that, right? No one's holding them accountable to it. Whereas now on Ethereum, if I run a full node and a validator creates a block where they mint themselves 1 million ETH, my node just rejects that. It just sees it as an empty block. And so do all the other like honest full nodes on the network. And this is like a super valuable property of Ethereum, because otherwise you'd be saying validators sort of get to choose the rules of the network and we all have to just accept them. There's no way to like reject them. So we want to maintain this property on Ethereum that like you can run a full node on a relatively accessible, piece of hardware. And today in practice, think of it as like a relatively recent laptop. Like you can't run a full node on, like a emerging markets tiny smartphone, but you can run a full node on like the average MacBook, to give you a rough idea.
Yeah.
Sorry, so this is kind of a detour. So we want to keep this property, make it easy to run a full node. The state is already a couple hundred gigabytes. If we go an order of magnitude beyond that, we compromise on that. So what we'd like to move to is a world where not everybody has to store all of the state all of the time. Imagine if like I run a full node now, I need to store not only my ENS name, but I need to store everybody's ENS names, on my local computer. And this is kind of redundant. So if you were in a world where like I'm running my node and I'm only storing like the data relevant to my addresses, and basically every node sort of operates that way, then you're less limited by, okay, how many total things happen on Ethereum? You're more limited by, how many things does each person want to store? And so this is what we call stateless Ethereum, where the idea is that you move to a world where nodes aren't expected to have the full state by default, but when they send a transaction, they send a part of the state proving, proving like their account balance effectively. So if I'm saying, I have 2 ETH and I want to send you 1 ETH, when I send that transaction, I'd send a copy saying like, here's my account in the state, here's where you can find it, here's its balance, it has 2 ETH, and then I'm sending 1 ETH to this other account, and you can know that, okay, I actually have the 2 ETH. And today our problem with doing that is just the way the state is set up in Ethereum is not conducive to sending small parts of it. I've explained this a couple of times already on different podcasts, but basically Ethereum state looks like a Christmas tree, where it's like this long and narrow data structure that if you want to send a proof, you have to go like from the top of this tree all the way to the bottom. And so you're sending like a ton of data with every transaction, and that just would not be doable, right? If you have to send like a couple megabytes of data every time you send a transaction, again, you would make it impossible for like a normal internet connection to just monitor like the mempool and stuff like that. So what we want to do on Ethereum, we want to move the state from like this big tall Christmas tree to a very narrow and long tree, more like a bush, and make it really easy for people to send small proofs where instead of having to send like this entire big slice of a tree, you just send a tiny spot. And the idea there is if we move to this model, then we don't need every node to store all of the state, and therefore we can raise the gas limit because we care less about the total state, but we care more about how much does every node store. So this was a long-winded way of saying we have like a scaling roadmap for both everything layer 2 and for layer 1. And this hard fork has shipped kind of the step 1 for both of these things. And over the next couple of years, we're looking to scale all of that further.
So yeah, I mean, I guess like in terms of timelines, is that like what I guess what are the next kind of like 12, 24 months look like specifically?
Yeah. So both those efforts of like stateless Ethereum and then what we call full sharding, where like you're verifying other people's data and doing these proofs, both of those are pretty significant efforts, like definitely more than a year away. But there are things that require like a subset of people to be focused on, but not necessarily everyone. So our rough plan at this point is in the next year or so, we'd like to ship a smaller upgrade with a bunch of like small but valuable features while we work on these larger ones in parallel. And this is kind of what we did this time around, where we just shipped this temporary data for L2s, but a bit less than a year before that, we had this other hard fork where we had beacon chain withdrawals and whatnot, a couple other features there. And we'd been working on those in parallel at the same time. So I think it probably looks something like this, where in the next year or so, you can expect like a smaller fork with a bunch of like, I don't want to say minor because they are quite valuable improvements, but like less technically complex improvements. And then in parallel, have people working on these larger efforts, which, hopefully ship soon after, but it gets much harder to predict timelines when you have really complex development.
Yeah, and I know Alex wants to ask some questions, but I do want to touch on one last thing. How are you thinking of like restaking? Is there any sort of like security risks with that? I know like some people have some people are worried that if Eigenlayer and all these different things kind of get too big, it could cause I don't know, could cause some huge issues with the network. I guess is that something you sort of buy into, or do you think it's relatively limited in terms of potential impact?
I think there are obviously risks, but in anywhere there's like a huge concentration of stake, you sort of create a risk. And maybe another way I think about decentralization and its value, it's like decorrelated failures, right? Like Ethereum is designed to operate in very suboptimal conditions. Like we know that this is like a distributed computer network. We don't expect everyone to be online all the time. And it's sort of designed to operate in like a pretty heavy state of chaos. And as long as like the failures that we see throughout the network are decorrelated, we can chug along pretty well. So I think, whether it's through restaking or liquid staking, or even, like centralized staking through like institutional stuff, this is really the lens through which I think about it, is like, is there some growing risk of a coordinated failure that impacts the protocol itself? And, the short answer is like, yes, as things grow, there typically are. But it also doesn't imply that because there's a risk of like a large coordinated failure that like Ethereum gets taken down or shut down or something like that. Like the level of failure for that to happen is quite high. So I don't think restaking today is anywhere near that. But
so what is that level? Just because like there's a couple sort of different centralizing vectors. I think there's Lido, there's potential Ethereum ETF, which I know some of them are also want to have staking built in. What level of centralization and concentration would start to get you very worried?
Yeah. So for the protocol, there's really three thresholds that are quite important. The first is a third of the stake. So a third of the stake is what prevents the network from finalizing. And maybe in layman's terms, like when something is finalized, it means that we know that to revert this transaction and this block, we'd have to burn somewhere around like a third of all ether. So it gives you, or a third of all staked ether, sorry. I'm not sure what the latest staking numbers are, but this is effectively tens of billions of dollars. So the way to think about this is that if you have like a finalized block, you have economic security on the order of tens of billions of dollars. For most transactions, unless you're sending hundreds of billions of dollars on Ethereum, which not many people do. I don't know if there's ever been transactions that big, but for everything below that, once a block is finalized, you have like a high assurance that just, it's not going to get reverted. Like the cost to revert it would be orders of magnitude bigger than the value settled. So this is like our first threshold. Is like a third of the network can prevent the network from agreeing to a finalized state, and that the network can continue in a non-finalized state. But what it does at that point is it starts to penalize anyone who is not voting on the current state along with everybody else, and basically burn a little bit of their ETH until you get 2/3 of the network to agree on one chain or another. So that's like the first important threshold. The second important threshold is 51%. So assume you have like two contending valid chains. If you have 51% of the stake, you can sort of control between chain A and chain B, which one is the one that's going to get finalized. So this doesn't mean you can do something like that's not part of the protocol, but between two valid alternatives, you get to choose which one is kind of the one we're going with. And then 2/3 of the stake is kind of the highest threshold, where if you have 2/3 of the stake, the same way if you have a third, you can prevent anyone from finalizing. If you have 2/3, you can finalize an arbitrary state. And this is why, for example, we're concerned about things like client supermajorities, because if there was, say, a bug in a client with 2/3 of the network, what would happen is this bug would finalize and create an invalid chain, which means everybody else, like the sort of 33% on the other side, would have to start burning the ETH of the validators who've done the invalid block on the big chain, which would result in a huge loss. You'd basically burn, more than half of that ETH on the chain for the chain without the bug to start finalizing again. So these are really like the three levels where it's like a third of the stake, you can prevent the chain from finalizing. Half of the stake, or more than half of the stake, you can decide between two valid fork choice candidates, and then 2/3 of the stake, you can make an invalid thing be finalized and cause a lot of harm to the network.
Awesome. Okay, that's great.
That's super interesting. I wanted to just jump in because in my intro, I totally forgot to mention, for people who didn't see the first episode, that you're with the Ethereum. You're a core developer with Ethereum, which is
I coordinate the core dev. So I don't write.
Important. Like, you're the coordinator of the core devs, which is like, everyone's like, why does this guy know so much about the inner workings of Ethereum? Like that should just to clarify for people. And the question that I have is in relation to that role, because this is like an open source piece of software, but it's this thing that's now worth hundreds of billions of dollars. It's got probably over 10,000 dApps plus millions of users and hundreds of millions of dollars of assets. And it's going through these changes. It's evolving, it's upgrading, it's becoming more useful. But it's you and these people who are doing that. And like, can you just quantify, like, how big is the team? how do you do that? Do you meet regularly? Are you like, I just don't have no, I feel like I have no comprehension of how it works to like upgrade a gigantic blockchain
Yeah.
network like Ethereum. And I think people who are listening to this might just find that kind of interesting.
Of course, yeah. And I'll say, before I dive into it, ethereum.org has a webpage about this. I think it's like /governance. So if people want to refer back to that, that's really a good resource. But at a high level, I'll start from like the start of like, we have an idea for a change to Ethereum to like a hard fork goes live, and kind of walk you through that process. We have, the way Ethereum is designed is there's a set of specifications that are independent from the production software that's run on the network. And this is the thing that we agree to and sort of debate over, which is different than, say, Bitcoin and most other blockchains. So the way Bitcoin works is Bitcoin has a specific piece of software, Bitcoin Core, which is the thing that you run. And then it also has maintainers and people, making changes to it, but they're like all upgrading or like working on the same code base.
Yeah.
The way Ethereum is set up is think of it as like an instruction manual. It's Python code, but it doesn't matter. The first version, the yellow paper, was like literally just math notation. So we just have like a set of rules that say, these are all the rules for Ethereum. This is like a valid transaction. This is a valid block. This is how the base fee and the burn works. This is how validators get rewarded or penalized. And we call those specifications. So we have all these specifications for everything. If you want to make a change to those specifications, we have this process called the Ethereum Improvement Proposal, which is just a template by which you sort of describe the change you want to make. You're saying, we want to add this new feature to Ethereum, or we want to change the gas price of this operation on Ethereum. And, the template asks you for some basic information, like, the rationale, why you want to do this, the specification. So like, imagine some things are pretty trivial, right? Where you're just saying, I want to change the price of this opcode. So you say, look, in this part of the specification, price goes from X to Y. But some things are huge, like, for example, this upgrade we just had where we add this whole new data storage network. It's like you have a whole technical specification for that. Obviously, a ton of test cases as well that are included in that. And that's kind of the public process by which we consider changes. So anyone can open Ethereum Improvement Proposal. And then every week we have these calls called the All Core Devs calls, where the different implementers of the production software get together and talk about these potential changes. So right now, there's about 10 implementation teams on Ethereum. 5 are focused on the proof of stake side of things, and 5 are focused on the execution side of things with the EVM.
Is this their full-time job, these people?
Yes. Yeah. So these are teams like, the Get team, the Prism team, Nethermind, whatnot. So we have these like 10 teams, each of which is effectively implementing only one half of the software. So like, you can't just run Geth, right? Like, you need to run Geth and a proof of stake client, and vice versa. And so every week they sort of debate potential changes, right? And over a period of months, we go from like a huge list of changes that people have proposed, and anyone is free to propose changes. So we sort of go through the whole list, debate them, usually try to figure out like, what's the most important thing we want to work on. Like in this case, for example, it was like this layer 2 scaling change. And then given that, how much capacity do we have for other things? And most of the times the other things have to be like non-overlapping, because if we're doing like a big complex change in one part of the protocol, we usually don't want to do like another change at the same time. And one example of this is for the merge, we had this big proof of stake change. We didn't want to do the validator withdrawal activation at the same time. So we split that in a separate fork, because it makes testing more complicated. So you want to like isolate the changes, come up with like a reasonable size and scope of change. Then we spend months and months and months testing this. So we have like the changes in the specification. The 10 production teams have to implement it. They have to not only not have bugs in their stuff, but also make sure that their stuff works with everybody else's stuff, like the 20 pairwise combinations all work. And we test this for months and months and months. At some point, we're confident that there's no more bugs. So Ethereum has these test nets that are live. So today there's 2, Holsky and Sepolia. And at that point, though, the people who write the software are not necessarily the people who run the software. So on testnets, there's like a high concentration of nodes run by client teams because there's kind of no reason to run a testnet node except testing, but they don't run the entire testnet. So what we do at this point is we put out an announcement saying this is the network upgrade and this is the software you have to download if you want to participate. But people running the nodes are the ones who have to like actually update their software and run this. And even more so when we get to mainnet. So when we get to mainnet, client teams run a tiny, tiny fraction of the network, both by number of nodes and by stake amount. Like there's tens of billions of dollars staked on Ethereum. Client teams don't like have that money. So when we put out a blog post like announcing the upgrade and client teams like announce it, then it's up to everyone to upgrade their software, right? Like it's in a way, it's like our job is kind of done. We're putting this out there for the community, and all the operators then have to choose to upgrade. And Ethereum has no like on-chain mechanism or anything like that to like trigger, activate, and upgrade. It's really just you update your software, and the new version of your software says, as of this point in time, the protocol rules change. So practically, it means we put out a blog post. Usually, there's like a few weeks where nothing happens to give time for people to upgrade. And then when this point in time is hit, everybody who's upgraded, their software starts using the new protocol rules. But anyone who's not upgraded would just stay on the old version of the protocol, right? And typically, sorry.
No. Just I'm just reacting to that. It's an amazingly not convoluted, but multi-stepped process.
Yeah. And typically, most upgrades, there's no significant like contingent that's holding out and like not upgrading. And the reason for that is usually because like any upgrade that can cause a fork and whatnot and be chaotic is something the developers of the network want to avoid. So they try to not put stuff in that's like super contentious. And there's a bunch of examples of like proposed changes that explicitly were not implemented because, of the risk of like splitting the network. But for example, when we had the merge, over 99% of the network upgraded to proof of stake, but there was a tiny contingent that stayed on proof of work. And you can't like force those people to upgrade, right? Like they can choose to run the proof of work software forever. And the idea is like, is a large enough part of the community on board with this upgrade?
Yeah. Well, I mean, in a lot of respects, it's not that dissimilar to there being a small part of the Bitcoin community that, believes in a different sort of fork of the Bitcoin network, even though
exactly.
Different and the process is different. I mean, in the end, like that's something that exists in all these different kinds of networks, right? I mean, it's not just like tech, it's like the social consensus that this is the useful canonical network we're all going to use because this is where all the value and all the activity is happening. And it seems to be that Ethereum goes through these upgrades and experiences that over and over again, right? Which I think speaks to the usefulness of the network and the fact that it's not like everyone is agreeing they're reaching consensus, right? But there's nobody telling anyone to do anything. It's more of this organic consensus process.
Yeah, and this is why it takes,
and that's why it takes
so long, right? Like obviously, if it was like 50 people and one CEO and like, you just did that, it would be quicker. But the thing you'd lose there is Ethereum probably has, I don't know, between 1 to 200 people that you'd consider like core developers who are like full-time working on part of like the basic infrastructure of the network. And the fact that we have like these 10 different client teams and, the Ethereum Foundation has like a testing team and stuff like that, it creates space for a lot more people to come and contribute compared to something like, say, like Bitcoin or something like that, where there's even though it's an open source project, only having a single code base creates like more friction, right? Like there's more contention between, okay, how are we going to do this thing? Whereas today on Ethereum, like different teams can try different things. And we've seen this over and over where like a new client team thinks that everybody else is doing things wrong. And it's like, great, you can show up, you can like build your own software from scratch and like become part of the process. And there's no way you might have convinced, the people who were there before that like they were all wrong because they're all smart people who think, they're doing the right thing. But like by having this open ecosystem, it allows new people to show up and like innovate on Ethereum. And this is a hugely valuable property.
Totally. Oh, that's a great way to sort of end the conversation, Tim. a hopeful note. Obviously, there's lots going on in the world of Ethereum, and we're very thankful for the role that you're playing in helping to steward and to coordinate, not to lead, but because there's no single leader, but to be so instrumental in its ongoing success. And really exciting. I learned a lot. I may have to go read some blog posts on the back of this so that I can just fill in the gaps in my own knowledge. And we'll make sure to include that post you mentioned in the show notes. For people who are interested in understanding and going deeper on this, where can they learn more, and how can they follow you?
Twitter and Warpcast are probably the two best places. So Twitter, I'm Tim Beiko at TIMBEIKO, and I'm Tim on Warpcast, so at TIM. Those are the best two places.
Awesome. Tim, great to see you. Thanks again for joining us. That's it for this week's episode of DeFi Decoded. We've got some more terrific guests teed up for the next little while. Tune in to stay in touch and to learn more about what's going on in the world of Web3. Thanks. Take care.
The information contained herein does not constitute an offer or solicitation by anyone in the United States or in any other jurisdiction in which such an offer or solicitation is not authorized, or to any person to whom it is unlawful to make such an offer or solicitation. Prospective investors who are not residents in Canada should contact their financial advisor to determine whether securities of the funds may be lawfully sold in their jurisdiction.